laws of reflection. This laws of reflection has one point, which is angle of incidence is always equal to the angle of reflection. If this is a plane, this is the normal to the plane. If a ray comes here, if this is the angle of inclination, or you can say angle of incidence, then if this ray reflects, say some angle r is there, so I should be equal to r. Angle of incidence should be equal to angle of reflection. Then this incident ray, second one is incident ray, the reflected ray, and the normal ray, this normal to this plane, all lie 1, 2, 3, this all 1, 2, 3 lie on the same plane. So these are the laws of reflection. Spherical mirrors. What are spherical mirrors? Most common type of curved mirrors, these are spherical mirrors. Mirrors in which the reflecting surface are spherical in shape, these are called spherical mirrors because of their shape. And reflective surface of a mirror, this can be curved inwards, it can be curved inwards or curved outwards. So because it can be like this, so it can be curved inwards or curved outwards. The one which is curved inward is known as concave mirror. This is known as concave mirror. And the one which is curved outwards, this is known as convex mirror. So these are both called as spherical mirrors. Some important terms with respect to reflection and refraction, like what is pole, principal axis, center of curvature, aperture, principal focus. Pole. What is a pole? The center of the reflecting surface, the center of the reflecting surface in a spherical mirror is a pole. In this figure, this P is a pole. This P is a pole. What is center of curvature? Reflecting surface in a spherical mirror has a center, and this is known as center of curvature. If this is your curve, then center of curvature in this convex mirror, it lies, if it is a convex mirror, it lies behind the mirror. It lies behind the mirror. But if it is concave, then it lies in front of the mirror, like this. So this is the center of curvature for this concave mirror, Then radius of curvature. What is the radius of curvature? See, this is a part of a circle. This is a part of a circle. So you can make a circle out of it. Here also you can make a circle. This is a circle. So there has to be some center. So the radius of this reflecting surface of this spherical mirror is known as radius of curvature. So this center is radius of curvature, and this, in this case, in this figure, for this concave mirror, the radius of curvature is R, capital R here, right? This is radius of curvature. And principal axis. What is the principal axis? See this, let me show you that from this point to this point, this is R. This we are talking about the radius of curvature. Now what is the principal axis? The straight line which is passing through the pole and the center of curvature. So this is the center of curvature and this is the pole. So center of curvature is here, pole is here. There is a line which is passing, and the line which is passing, a straight line which is passing through the pole and the center of curvature, In this case, you can call it for both the mirrors, concave, convex, that is spherical mirror. This is known as the principal axis. So this is your principal axis. Here in this case, this dotted black line or the this line is called as principal axis. What is principal focus? What is the principal focus here? The reflected ray appear to come from a point on the principal axis. The reflected ray appear to come from a point on the principal axis. So this is known as the principal focus. In this case, this point is a principal focus because the reflected ray appear to come from this point on the principal axis. We'll know about this more, but for the time being, this is your principal focus. Focal length. The focal length is the distance from the pole, this pole in a spherical mirror, to the focal, as is to what? From pole to principal focus. We just knew that this is principal focus and this is the pole. So if this is a pole and this is principal focus, say f, the distance between these two is known as the focal length, and this is represented by f. Then aperture. What is the aperture? The diameter of the reflecting surface is known as aperture. The diameter, see, this is a diameter. So because this is a diameter, the radius of curvature is twice the focal length. Radius of curvature is twice the focal length. The diameter of the reflecting surface is defined as the aperture. So aperture is basically the diameter of the reflecting surface. And as I just suggested, the radius of curvature is twice the focal length.